Okay, so what we're going to talk about in this video is carbon cycling. And I'm going to construct a carbon cycle. That is one of the key things that you need to be able to do. And you need really to have that skill to be able to start thinking about where the carbon is and where the different sinks are and how the fluxes occur between the different sinks. Okay, so what I've started to look at is all the different sinks that I can think of. So here we go. We've got the autotrophs, which could be in the sea or on the land. We've got our heterotrophs. So those are interlinked because we've got carbon dioxide in the air. This flux here, which is where the carbon dioxide is trapped inside of these autotrophs in the process known as photosynthesis, where they turn those that carbon dioxide into a complex carbon compound. This can then be eaten by heterotrophs. Okay, heterotrophs, bunnies don't eat themselves, but heterotrophs eat other heterotrophs. Think of the primary, secondary consumers we talked about before, but that causes cycling between heterotrophs of the complex carbon compounds. So this is through feeding as well. Now, at each stage, some of the carbon is lost back into the atmosphere. And this is through the process of respiration that occurs in the mitochondria. Okay, so that's the first part of our cycle. Now, at the end of the autotroph's life, or the heterotroph's life, they will die. The heterotroph also will make waste by excretion. Okay, and at that point, you see these little friends here. These are the next sink that we've got, and these are this one is something that ingests waste internally, so it's a detritivore. Oh, there you go. And this one is a sapropod. Saprotroph, sorry. The reason it's saprotroph is because it will release its digestive juices and digest externally. Okay, so that's what happens there. And what they do is they then respire and release the carbon dioxide back into the atmosphere. Okie doke. Right. What can also happen is that these organisms might not completely decompose by the actions of these organisms. What could happen is they could either, how can I draw this? There you go. They could go to a different way. So this is a peat bog. Peat bog. And peat bogs have low oxygen levels. So the peat bog has low pH and a low CO2, and as a result what you can get are things like woolly mammoths found inside of peat bogs, humans with their hair and their skin that have been there for hundreds and hundreds of years. In fact, I can highly recommend going to some museums in Ireland when we get a chance, and you can go and see some of these men that have been dragged out of peat bogs that look like they've just died yesterday. Okay, so there's not decomposition happening, so those complex carbon compounds are being trapped within this peat bog. Okay, so this acts as a sink. Now what can happen is the human activity is that this is sometimes used as a fuel, and then it's burnt, and all of the complex carbon compounds are broken down into carbon dioxide, and that's released into the air. Okay, now another thing that can happen is you can get some partially fossilised organisms and they're partially decomposed, partially fossilised, and what happens is they can collect inside of accumulating porous rocks. Okay, and this is the formation of oil and coal. Okay, equally, in the same way as the peat can be burnt, so can the coal and oil, and we know that that's a main source of fuel when heating our homes, when making electricity, making petrol. All of those things are driven by the burning of fossil fuels. Okay, there's the third fossil fuel that we haven't spoken about, which is methane, which is gas. Okay, now in the same way that some of these autotrophs can be broken down by something called a methanogenic archaean. Okay, these are tiny bacteria that work in soil with no oxygen. And what they do is they'll turn these complex carbon compounds into methane. Some of that gets trapped underground. Until it gets dug out by humans and then goes into this cycle, so combustion again. Some of it goes up into the air where it's oxidized. And then turns back into carbon dioxide. Okay. One place we haven't looked at is the oceans. Now the oceans hold a lot of carbon dioxide. Okay, so this dissolves in the form of dissolved CO2 and HCO3, hydrogen carbonate ions. Okay. Now, high concentrations of these can be problematic, and we'll look at that more in the climate change section. Another way that the carbon dioxide can get trapped is in organisms. This looks like a plant, it's not meant to be. This is a coral, and I'm going to draw some mollusks as well. Be a shell. There you go. Anyway, right, so mollusks and coral contain calcium carbonate. Okay, so that is a store of carbon dioxide. Now, over time, what can happen this can become fossilised and get converted into something called limestone. Okay, so limestone is another sink for the carbon dioxide. It's a type of rock, and it contains carbon dioxide. Okay, there you go. That is my carbon cycle. And they're the key sinks that you need to know, and processes.